Welcome to the presentation on the second part of the principles of stratigraphy. Here you find that in the first part we have defined stratigraphy and also the terms which are closely associated with stratigraphic principles. We found that the stratigraphic principles form the foundation for the study of stratigraphy as a science. Again, we found the differences between law, hypothesis and principle. Relative date and absolute date are two terms frequently used in the description of the principles of stratigraphy. This also we have seen in the first part of the presentation. Then we went on to list the important principles or major principles in stratigraphy. These principles are 8 in number. We have seen the first 4 principles. The principle of uniformitarianism as stated by James Hutton and later on popularized by Charles Lyell forms a milestone in the study of geology. In fact, it revolutionized not only historical sciences, but contributed a lot to the science as a whole, the study of science as a whole. Principle of uniformitarianism in fact replaced many of the existing concepts on time and also earth processes. It made important contributions in making geology a field science and also told the immensity of time involved in geological processes. So, the principle of uniformitarianism is a milestone in the study of geology as a whole. The second principle, that is the principle of superposition, is a very simple one. It is a self-explanatory one. It says that undisturbed sequences of rock layers shows that the uppermost layer will be the youngest and the bottommost layer will be the oldest. But again remember that undisturbed sequences are very rare in nature. So, we have to interpret and make using other principles and bring it to the undisturbed position before giving the ages for the different layers in a sequence. The third one shows that the principle of original horizontality. Rock layers are deposited in a horizontal manner initially. So, this is true, but again it is possible that in some other cases you may have inclined beds formed initially itself. For example, when deposition takes place in sand dunes, we find some sort of inclination for the initially formed beds. The fourth one we discussed was the principle of lateral continuity. So, lateral continuity says that initially when rock layers are formed, it will be extending laterally in an indefinite manner. It means that we will not be in a position to see the edges of rock layers as such. Again, it does not mean that a single layer of rock may extend throughout the earth. It does not mean so. So, it has to be understood in the formation of a layer of rock within a basin or a sub basin. So, now let us see the other 4 principles. So, here you have the principle of cross cutting relationship. This again is a contribution of James Hutton, who lived between 1726 and 1797. James Hutton's principle says that we have to depend on other principles also in interpreting the formation of or the sequence of events that have taken place in a particular place. Instead of depending on the principle of superposition, lateral continuity and principle of original horizontality alone, we may have to depend on other principles including the principle of cross cutting relationship. Let us see what this principle says. It says that geological feature which cuts another is the younger of the 2 features. Geological feature which cuts another is the younger of the 2 features. It means that when 2 geological features are found and one is cutting across the other, the one which is cut is the older one and the one which is continuous one is the later one. So, if you have a series of mineral veins in an area, then you will find that you, depending upon the continuity of the vein, the most continuous vein will be the youngest and the least continuous vein will be the oldest. Similarly, if a number of faults are there in an area, in the among the faults we will find that that fault which has disturbed all the other faults will be the youngest. So, this sort of cross-cutting relationship is of utmost importance in understanding the stratigraphy of an area. So, here you find that this is very useful in during a field work, geological field work in an area. Then again intrusive, structural and erosional contacts show cross-cutting relationships. Intrusive contacts means granite intrusion or a gabbroic intrusion, dunite intrusion. So, igneous intrusions they will tell us something about the age of rocks in an area. Similarly, structural contacts like faults and joints will help us to know about the different events, sequence of events that have happened in that area. The third one, the erosional features, that is erosional contacts means unconformities will also help in knowing about the different sequence of events in an area. Let us see one by one. See, the first one of the cross-cutting relationship says that any intrusive body must be younger than all the rocks that are intruded by it. It says that when you have an intrusion in a rock, that intrusion is younger to the rock which have been intruded by it. For example, a gabbro intrusion is found within a sandstone body. It means that that gabbro intrusion is younger than the gabbro intrusion is younger than the sandstone body. The second one says that faults are younger than all rocks that they displace, and faults are older than the oldest stratum that unconformably overlaps them. It means that in a sequence of rocks which have been affected by faulting, those rocks which have been affected, those layers of rocks which have been affected by fault are older than the fault, and those which have not been affected by the faults are younger than the fault. The third one says that rocks below an unconformity are older than the rocks above and younger than the rocks below. So, if you find two sequence of rocks, there may be an unconformity in between the two. This unconformity will help us to date the rocks, to talk about the relative ages of rocks. The rocks below the unconformity are older than the unconformity, and those above the unconformity are younger than the unconformity. As you know that unconformities are planes which represent a period of erosion or non-deposition or a combination of both. The last one which says that in a series of cross-cutting veins, mineral veins, the youngest one will be the most continuous and the oldest one will be the least continuous. So, in an area you may find that this is very evident during field work. You may find a number of veins. Let us say that pegmatite veins are found in an area, and you have several types of pegmatite veins. Some of the veins are pink, some are grey, some are white and all. You go on finding out which is the most continuous vein. That continuous pegmatite vein will be the youngest one compared to the other veins in the area. Let us see these the explanation for these principles with the help of certain figures and photographs. So, here we have a figure which shows a sequence of rocks here. C, B and A are three rock layers formed in an area. If you apply the principle of superposition, C is the oldest and A is the youngest in the area. This series of rocks CBA, they have been affected by an intrusion D. D is an igneous intrusion, and this intrusion cuts through C, B and A. D is the intrusion. But again you find that there is a fault which has affected the three layers of rock as well as the intrusion. So, which means that C, B, A and D have been affected by faulting. So, if you order the event sequence of event, you will find that the youngest event will be the faulting. This before that you have the intrusion taking place, and even before that you have the formation of the 3 layers of rocks. Thus, you will be able to relatively date the events from this section. This figure is a section which shows the different events. Let us see another figure. So, here we have another figure in which you find that the older layers are folded, G, F, E, D, C and H are folded, whereas the younger layers remain horizontal. So, in between that there is an undulating surface which is the unconformity. So, as per the cross cutting relationship, we will say that those rock layers which are found below the unconformity are older than the unconformity, which means that G, F, E, D, C, H are older than the unconformity, and those which are found above the unconformity are younger than the unconformity. B and A are younger than the unconformity. Remember that the rock layers G, F, E, D, C and H were initially deposited in a horizontal manner, later on they were folded, and after that there was a period of erosion or non-deposition, and an unconformity surface formed. Over that you have the deposition of 2 layers B and A in a horizontal manner. So, thus we have used the unconformity surface for dating the different events in that area. Still another figure which shows that there are rock layers E, C, B and A. These 4 layers of sedimentary rocks are there, and of this we find that an intrusion have affected E, C and B. E, C and B have been affected by an intrusion D. So, we can definitely say that D is younger to E, C and B. Maybe that A was formed at a later time, but we do not see an undulating surface there, and if at all it is there, then A will belong to another series of rocks. But instead of that, it is possible that initially itself all the 4 layers were formed, but the magma was not forceful enough to penetrate through A. So, it remained till till the B layer was reached. Definitely D is younger than E, C and B. Okay. Now, we have photographs here. You can see an intrusion here which has affected the bottom layers. Up to this it has affected, and on top of that another set of layers are there which have not been affected. It means that the bottom set of layers, this reddish layers, have been intruded by some igneous intrusion, and after that you have the formation of a new set of layers. So, 2 series of layers are there, out of that one have been affected by an intrusion. That intrusion is younger than the bottom set of layers and older than the upper surface of upper series of layers. Here is another example. This is an example where a minor fault is shown. You can see the minor fault here. A conglomerate horizon has been displaced. So, it shows that the conglomerate horizon was initially formed. After that faulting has taken place. So, faulting is a later event. This is an example from Kurnool, southeast of Kurnool in Andhra Pradesh. Now, here again another example where you find that there is an unconformity separating the quartzite horizon from a shale horizon. So, the light colored one is shale and the upper one is quartzite. There is an unconformity between the two. So, shale is older than the unconformity and quartzite is younger than the unconformity. So, here a series of veins are shown here. A number of veins there. If you watch closely, some of these veins might be continuous and some of them are discontinuous. You have to trace that vein which is the most continuous one to find out to find which is the youngest one. The most continuous vein here will be the youngest and the least continuous vein will be the oldest. So, cross cutting relationship plays a very important role in understanding the different sequence of events in an area. Now, we will go for another principle, the sixth principle, which is called as the principle of inclusions and components. So, here this was stated by Charles Lyell, in fact, who has popularized the principle of uniformitarianism. He was the one who gave this in his book, which is considered to be the first textbook in geology, that is the Principles of Geology, between 1830 and 1833, which was published. Here you find that it states that with sedimentary rocks, if inclusions are found in a formation, then the inclusions must be older than the formation that contains them. So, if you take a sedimentary rock, within the sediment rock, we will call that rock as X. You find inclusions of another rock Y, then we will say that Y is older than X. This is the principle. So, this is applicable to igneous rocks also. When you find that xenolith, that is xenolith means foreign fragment. If foreign fragments are found within an igneous rock, that fragment is older than the rock which enclosed that fragment. Okay? That is, if you have pieces of gabbro in a granitic intrusion, that pieces of gabbro found within the granite is older than the granite rock itself. So, this is a very important principle that let us see with see this with the help of some figures. Here you can see two examples here. Here you find that layer A is there, layer B is there. So, and there is an intrusion here. This intrusion contains pieces of B. So, which says that B is older than this intrusion. Definitely B is older than the intrusion. So, after the formation of B only, this intrusion has taken place. So, the inclusion B, this inclusion B is an earlier one than the formation of intrusion C. In the second figure you have there you find that you have an intrusion C and two layers are there, A and B. In layer B you have pieces of C. Pieces of this intruded rock C is found within B. It means that initially A was formed, within A you have the intrusion C, and after the formation of C there was deposition of B, and this B contains small inclusions of the rock C. So, this is a very self-explanatory one, and especially during the field work, this helps a lot in interpreting which one has formed first. Then you have two figures here, two figures which tries to help in interpreting this principle of inclusions. In the first figure we find that pieces of sandstone are found within granite. It means that this sandstone is an earlier formed one. Therefore, inclusion of sandstone is found within granite. In the second figure you find that pieces of granite are found within sandstone, which means that granite is the earlier one and earlier one formed, and sandstone is later formed. Sandstone contains inclusions of granite. So, granite is the older rock in the second figure. So, we will go for the seventh principle, that is the principle of fossil succession, otherwise it is called principle of faunal succession. So, because faunal succession means initially it was thought that only animal remains were considered as fossils, but later on plant remains are also considered as fossils. Today both plant remains and animal remains are considered as fossils. What is a fossil? Fossils are the remains of organisms which lived in the past, or the activity of the organisms preserved in the rocks also will be considered as fossils. So, earlier in the in ancient times it was found that it was believed that these fossils are sports or jokes of nature. Nobody understood the value of these fossils, although Aristotle, Leonardo da Vinci and others said that they might be the remains of organisms which lived in the past. At the same time, in the 17th century, Robert Hooke, a British scientist, he said that fossils may be used for finding the age of rocks that enclose these fossils. So, probably he was the first one to talk about the use of fossils for finding the ages of rocks that contain them. Let us see that the contribution of William Smith. William Smith was a person who did not have formal education at all. He was employed as a helper in the construction of canals in southern England. At that time, a lot of canals were being dug in England for the transportation of coal for industrial use. So, he was helping the engineer there, and later on he became a surveyor. Because of his dedication, he was promoted to the role of a surveyor. So, while digging the canals, he found that there is some sort of order in the fossils that are found in different layers of rocks. So, he watched them closely and he collected these evidences for a number of years before arriving at the principle of fossil succession or faunal succession. But remember that his observations were simply empirical. He did not have any education or idea about biology or organic evolution or the distribution of animals in space and time. But in the rocks, when he found that there is some sort of system in which the fossils are found. So, he gave the principle of fossil succession. When William Smith was working in southern England, another group was working in the Paris basin. Two professors, George Cuvier and Alexander Brongniart, both professors in the University of Paris, they were working on Paris basin, and they also arrived at a similar conclusion. In the words of William Smith, it is said that groups of fossils appear in a chronological order through their vertical placement in sedimentary rocks. That is, if you trace a sequence of vertical sequence of rock layers, there is some sort of order in the arrangement of fossils in these layers. That is the principle of fossil succession. Let us see. This is if you see it closely, you will find that it is something very related to the principle of superposition. In the principle of superposition, we say that the oldest layer is at the bottom and the youngest layer is at the top, that is the topmost layer is the youngest. So, here William Smith observed that the fossils which were found at the bottommost layer were the most primitive ones, and the fossils which were enclosed in the topmost layers were the more advanced ones. So, he found that there is some sort of change from the top to the bottom. The fossils are not haphazardly placed in rock layers, but instead they are arranged in some sort of orderly manner. that is the conclusion that he arrived at, although he did not know anything about organic evolution. So, he found that fossil organisms succeed one another in time in a definite and recognizable order, whereas each distinct organism existed for a specific time interval. That is, after a particular interval, fossils or organisms became extinct. He did not talk about extinction and all. He said that these organisms had lived for a specific time and they have disappeared. So, that is extinction. So, what is the use of this principle of fossil section? It helps the geologist to find the age of a particular rock layer and based on the fossil embedded in it. Here there is an important presumption, in the sense that the fossils that are found within a layer of a rock is something which has formed at the same time as the rocks were formed. So, in other words, we can say that if fossils, if organisms had lived at the topmost layer and microorganisms if they had lived in the topmost layer, and after some time through some fractures in fishes, if they have migrated to the bottommost layer and fossilized there, then they will not give the age of these rocks. That means those fossils will be called as leaked fossils. So, in situ fossils, only in situ fossils we have to use for dating the rock or finding the age of the rocks. Yes, when you discover such sort of fossils, based on the type of fossils present, we will be able to locate coal deposits if they are indications of the presence of coal in an area. So, using that you can find coal deposits. Not only coal deposits, oil deposits can be found. A number of oil deposits have also been discovered in this manner. So, this is a figure which explains, in fact, this one clearly explains, you have the oldest layer here, the youngest layer here, and you have a succession of fossils. The most primitive one and the most advanced one are found here. So, here you have fossilized layers are found. If you are searching for fossils, you will find that the oldest fossil will be found at the bottom, and the most advanced fossil will be found at the top of this sequence of layers. Well, the last principle, that is called as the principle of fossil assemblages. Principle of fossil assemblages was also stated by William Smith. He says that characteristic groups of fossils define unique geological ages. It means that the age of a rock will be reflected by the fossils that are present there. So, similar assemblages of fossils in rocks indicate similar ages. For example, I find a set of layers of rocks in a set of layers of rocks in an area which contain certain fossils. Let us say that the place location is A, and far away from here I find another set of layers in location B. They also contain similar fossils. Then I say that these two layers of rocks have formed at the same time, because they contain similar fossils. So, that is similar assemblages of fossils indicate similar ages, although these two places have been separated by long distances. So, they help in understanding the ages of rocks. So, fossils also are good for correlating isolated outcrops either regionally across the continents. This is not applicable to small areas alone. So, if fossils are found in India and they are found in further places, maybe in another country, Sri Lanka, then I mean the rock layers of these two places, they contain similar fossils, then I will say that they have similar ages. Similarly, you might have heard about Gondwana land and all, and in that you talk about our Asian continent being in physical contact with Africa and South America. So, there also you use these similar assemblages of fossils to talk about their physical continuity and similarity in ages of rocks in these continents. So, here you have a figure which shows location A and location B, and these two locations have similar assemblages of fossils and they have been correlated. So, similar assemblages of fossils indicate here this set of layers, and in location B this set of layers they are of similar age. That is the use of these principles. Okay. Let me summarize what we have discussed so far in these two presentations together. We will say that differences among the terms hypothesis, principles and theory and law were explained. Then principle of stratigraphy is the foundation for the stratigraphy as a science, and the 8 guiding principles were discussed and elaborated with the help of diagrams and images. Then relation among the different principles were described, and utility of these principles were also stated. Without these principles, stratigraphy as a science will not survive. Well, what is the conclusion that we can arrive at? Remember that when we are doing a field work in an area, our idea is to find out the history of that particular part of the earth. For understanding the different, for having the idea of history of that place, we should know the sequence of events, sequence of geological events that have taken place in this area. So, initially all these were done with the help of these principles, stratigraphic principles, which help us to know about the different events that have taken place in that particular area. Once we know the sequence of events in one area, we can correlate with the sequence of events in another area, and thus we can have a common history for these two areas. So, this is very important in the study of the history of the earth as a whole. So, forms the foundation. So, forms the foundation of stratigraphic studies, these principles. The next one helps in finding out the relative ages of rocks, although we may talk about the absolute ages here, and to find the absolute age of rocks using radiometric method, it is a very costly and time consuming process. And the third one helps in reconstructing the geology history of an area, helps in the exploration of mineral and fuel deposits, and the last one, these principles support biological evolution. So, stratigraphic principles are very important in the study of stratigraphy, not only stratigraphy, but the study of the earth as a whole. It helps to reconstruct the history of the earth as a whole. Thank you very much for your patient listening and watching this presentation. Once again, thank you very much.